Today frames are being positioned and fixed. The fixing is by powder driven nail. You can see all three carpenters have got ear protection. Here the excess damp-proof course needs to be removed in order to confirm the set out. Although NZS 3604 lists a tolerance on plan of 15mm, it's best to work as accurately as practicable to the set out line so that the next frames will fit properly. Here the top of the frame is nailed to the previous frame and vertical alignment is checked. Deviation from the vertical in NZS 3604 can only be 5mm in a 2.4 metre length. The frames need 2 or 3 people to manoeuvre them into position. Each frame is numbered, identified on shop drawings, and the stack of frames is arranged in an order to facilitate easy assembly. Even the identification of inside and outside of each frame is important. Here the team are positioning the frame, and is not helped by the windy conditions. The set-out marks have been placed on the concrete for the inner face of the frame. Here you can see by the shadow of the bottom plate on the left hand end that the concrete has some tolerance, although probably within allowable limits. If the frame had been positioned from the external face of the concrete rather than the set-out marks, the next frame would not fit. The difference is small, and here it's accentuated by the angle of the sun. A temporary block is being nailed to the slab. It's used to fix the temporary brace. This general view shows the lower level wall framing has been completed. Work is now proceeding on the erection of steel columns and beams. The beams come made to size with end plates and fixing plates and already painted. Here we can see how the steel member is integrated into the timber structure. Each prefabricated steel member comes labelled. And this view of the garage shows the amount of temporary bracing required for the long southern wall. There's a steel beam ready to be installed, just sitting on temporary timbers. And this is a good shot of the strengthening web at the end of the universal beam. Steel columns are being inserted into the timber wall. This one on the left is prepared and the one on the right is being installed. And this is just a view of material for box section columns. Holes are being drilled through the bottom plate, and this close-up shows a hole through the bracket. And here we can see the extent of timber needed: studs, top and bottom plates, dwellings, lintels, and this one's a proprietary product. This shot shows the steel channel section portal frame. The steel section further back is a universal beam, and it's used so that the timber floor joists can sit on the flange. Note the temporary bracing and blocking of the joists. The close-up of the external portal shows the fixing and the tolerances required. And this is the other end. Here we're looking at how the UBs are integrated into the timber construction. One with a welded plate attached to 4 studs and a steel-to-steel joint by bolting. These built-up sections have a timber top and bottom chord, spaced apart by timber and given strength by the metal struts pressed into the timber. We call it the posi strut system. When the working height of the structure gets above a certain height, it's necessary to use scaffolding. A view of the laminated veneer lumber used over the garage. The close-up shows the veneers all pressed together. And this is a structural braced panel beside the garage entrance. Note the careful placement of the nails. The particle board flooring has been delivered and stacked on the upper floor in readiness for laying. At this point there's a considerable load on the steel lintel. And on this corner the introduction of the holding arm bolt has spalled off the concrete. It will require some restoration. Wall frames have been completed on the upper level. Note the extent of temporary bracing on both levels, necessary until sheet linings and bracing panels are installed. A start has been made on the roof trusses. These are a simple single slope truss at close centres. This view of the second level gives an idea of the height of the building. And as such, it's necessary to use scaffolding to provide an external working platform. The planks are aluminium and the whole structure is a pipe and clamp system. This view from the east shows the trusses have been fitted over the garage. Each joint of the truss is held together by a gang nail plate. This shot in the family and dining area shows the posi-stripe joists in position and the flooring above. Show an overview of the nearly completed framing. You can tell by the sound of the saw there's still framing work required. This shot is of the joists to the upper floor. These are rafters to a flat roof. Here we're looking at the tube scaffolding, showing the handrails. And the timbered roof trusses have had an additional member fixed. As the building gets higher, it becomes necessary to use scaffolding. Different scaffolding is used in parts. This yellow scaffolding is of the frame variety and uses aluminium planks. And this galvanised one shows the use of clamps for the diagonal braces. Material delivered to the site needs to be kept neat and tidy so it's easy to access when required. Note the use of dunnage to keep the material clear of the ground. A start's been made on the drainage. While much of the excavation for the foul water drain has been done by machine, it's often necessary to finish the levelling by hand. The machine has a spike for breaking up the heavy clay. The movement of the machine indicates how hard and puggy the ground is despite the recent rain. This shot shows a supply of plastic pipes that will be used. Note the flexibility of the material. Having used a spike, the operator now fits the small bucket to remove the spoil. Here the pieces of pipework are being assembled. And this is a view of the machine working close to the garage slab. This is a closer look. The range of fittings supplied, different sizes, angles, all designed to fit snugly over the pipe. There have been several days of rain, and the result is clearly visible here. The site has become muddy, making delivery of materials difficult. And the particle board flooring shows pools of water. These sheets of flooring grade particle board contain a weatherproofing agent, which means the flooring will withstand a certain amount of wetting. But there's a limitation to how long the sheets will stand this treatment. Concrete slab also has water ponding on it. While the concrete can withstand this, it is the adjacent timbers that suffer. Here's the area the drain layer was working on last time. It's been backfilled over the drain. Even the garage area is holding water on the slab. This is the vent to the installed drain. Here we can clearly see the wetting of the bottom plate and ends of the studs. There is now extensive use of these scaffolding frames to gain access to the sides of the building. Fascia boards have been fitted to the roof trusses. The pre-assembled trusses still require on-site work before any roofing can be fixed. This is a close-up of the aluminium scaffolding planks with their hooked ends that will fit over the pipe structure. On the top story, a string line has been set up as a reference, as there is more timber work to do. Here the carpenters are constructing the timber work to a valley between two parts of the roof. Blocking pieces are used between the trusses. Pre-primed fascia boards have been fitted at the lower level. This is finishing work and the boards need to be fitted accurately into line. Here we're looking at the joints between the fascia boards, the internal corner being mitered, the external corner left with an overlap to be trimmed to size later. And here's the profile, primed on four sides. Here we're looking at the purlins on top of the roof trusses at the family dining area. The purlins are fixed against uplift by use of Z nails. Oh, and there's an additional sign indicating the electrician has been. This view of the east side shows the fitted fascia boards. This is the upper edge of a single slate roof over the garage. So both internal and external corners have been mitered. This view from the south on an adjacent section, there's a sign indicating the section's been sold, and if a house is built it's unlikely that very much of this elevation will be seen in future. This close-up of the framing shows the metal retaining straps. Back to the fascia boards. This longer one on the east side may have been easy to draw in elevation, but the boards come in limited lengths. And around the corner, the late afternoon sun shows us the extent of nailing required. Roofing on the lower level has been fixed. This view underneath of the family dining area shows the building ramp and the chicken mesh used to support the ramp. We've seen this corner before at the dining and rumpus rooms. Now the valley gutter has been done. You can see the V profile of the gutter. This shot shows the ends of the sheet with their overlap with the fascia. Each change of direction may be easy to draw. Executing it's a little bit more difficult. And this shot from above shows how every sheet needs to be cut at an angle. Also shows the fixing through the crest of the profile. On this side the initial fixing of the sheet is not complete. Timber is used to secure the wrap temporarily. Generous amounts of wrap are used to ensure coverage. Now this view of the upper level is looking at the steel frame and you can see the generous bolt fixing of the timber plate. Here you get an impression of how much timber is involved. Even with the prefabrication of wall units, roof trusses, there's still a lot of additional carpentry to do. And looking at this corner with the packers inserted, there are 7 thicknesses of timber.